Kuzuzangpo, welcome to Bhutan e-learning program. I am Namgyal Hadin from Motiethang Higher Secondary School. Today I will be presenting to you a lesson on chemical bond for Key Stage 4, that is for classes 9 and 10. Before I start my lesson, let me introduce to you the lesson objectives. At the end of the lesson, we will be able to define the chemical bonds, name the three types of chemical bonds, state the conditions necessary for the formation of covalent and ionic bonds, and mention the examples of covalent, ionic, and metallic substances. Now, before I start the lesson, let me ask you one question. Why do atoms form bonds? Okay, let me give you an analogy. We have lots of daily life experiences that will relate us to answer the question, why do atoms form bond? For example, a stone on a hilltop rolls down on a ground level. A man sitting on a treetop would like to come down to the ground. Why do you think so? Did you ever wonder? That's because the stone on the hilltop and man on the tree is at the higher energy level. And as they come down on the ground, they lose certain amount of energy and they are at the stable state. Likewise, why do atoms form bond? So atom needs to be in a stable state. So in order to be in the stable state, they need to have noble gas electronic configuration. So atom requires 8 electrons in its outermost shells to be stable. All atoms undergo chemical reaction to attain 8 electrons in its outermost shell. So atoms attaining 8 electrons in this outermost shell is said to have octet configuration. So I have an example on the board here. Please observe carefully. There's an atom with 3 electrons in its outermost shell. Now I have a question for you. Is this atom stable? Yes, you're correct. The atom is not stable. Now, in order for an atom to be stable, it needs to have noble gas electronic configuration, that is, have 8 electrons in its outermost shell. We call it noble gas electronic configuration. So I have some examples. You can look on the board again. Neon, argon, krypton, xenon, and radium. And you can see all of them have 8 electrons in their outermost shell. They have different numbers of shells, but the outermost shell have 8 electrons each, except for helium. Helium is also a noble gas, but helium is not having 8 electrons. It has 2 electrons, and it is, again, stable because helium is having only 1 shell. You can look at the example. Helium atom is given there. It's having only 2 electrons in its valence shell, and it is stable. The other example is an atom of hydrogen. Hydrogen has 1 valence electron, and it achieves its stability by gaining or sharing 1 electron from other atoms. Now, I have another question. What is duplet rule? Guess for some time. Okay, here's the answer. An atom with only 1 shell, like helium, requires 2 electrons to be stable. And hydrogen, 1 shell, only 1 electron, it is not stable. For hydrogen to be stable, it needs 1 more electron. How do atoms form bond now? Atoms form bond by losing, gaining, sharing of electrons. And why do they need to form bonds in the first place? Why do they form bonds? They form bonds to be stable or to attain noble gas electronic configuration. And bonds are formed by losing, gaining, or sharing electrons. Which of the atoms gains, loses, or shares electron? I have lithium atom, fluorine atom, and 2 atoms of hydrogen. So to understand this one, we need to know the nature of the atom, whether it's metal or non-metal. So before answering this question, let us look at the nature of the atom. Metal atoms. Metal atoms have valence electron 1, 2, or 3. And nonmetal atoms have valence electrons 4, 5, 6, or 7. Metal atoms have tendency to lose electron and become stable, and nonmetal atoms have tendency to gain electron and become stable. How would these atoms achieve stable state now? The atoms are lithium, fluorine, and 2 atoms of hydrogen. Let us look at lithium atom. Lithium atom has 1 electron in its outermost shell, and fluorine atom 7 electrons in outermost shell, and 2 atoms of hydrogen have 1 electron each. Okay. Now, by looking at the nature, lithium is metal, so it's going to lose 1 electron. Fluorine is a nonmetal, it's going to gain 1 electron, and 2 atoms of hydrogen, they are neither going to lose nor going to gain, so they will be sharing a pair of electron. So now look at that lithium atom. Lithium is losing 1 electron and lithium has 1 shell and has 2 electrons in its outermost shell, and it is stable now. Fluorine atom is having only 7 electrons in its outermost shell, and it is gaining 1 electron, and it has 8 electrons in its outermost shell, and now this fluorine atom is also stable. Look at the 2 atoms of hydrogen. What they're going to do? They are sharing electrons, and both the atoms have 2 electrons in their outermost shell, and they are stable now. We're going to look at the types of bond. The first type is ionic bond. Let us see how ionic bonds are formed. In order to understand ionic bond, let us take an example. Here I have 2 atoms, atom of sodium and atom of chlorine. Sodium atom contains 11 electrons and 11 protons. The net charge on sodium atom is 0 because it contains 11 protons and 11 electrons, meaning 11 positive charges and 11 negative charges. And same thing on the chlorine atom. Chlorine atom contains 17 electrons and 17 protons. Net charge on chlorine atom is also 0 because it also contains equal number of electron and proton. Now, when you look at the structure, sodium atom, in the last shell, there is only 1 electron, and in the chlorine atom, in the last shell, there are only 7 electrons. Both the atoms are not stable. So sodium atom, in order to attain stability, it needs to lose 1 electron, and chlorine atom, in order to gain stability, it needs to gain 1 electron. So when sodium atom loses 1 electron and chlorine atom gains 1 electron, they become charged. Sodium atom losing 1 electron becomes positively charged, and chlorine atom gaining 1 electron becomes negatively charged. And when these two oppositely charged atoms or ions are placed together, there exists a force of attraction. And this force of attraction is called ionic bond. The positively charged atom here is called cations, and negatively charged atom is called anions. And this is how an ionic bond is formed. Since ionic compounds are held together by very strong electrostatic force of attraction, they exist in solid state, they are hard and brittle, they are crystalline in nature, and they have high melting point and boiling point. Let us practice the formation of ionic compounds. First, calcium chloride. Second, potassium chloride. So let us see one by one how each one of them are formed. First, let us look at formation of calcium chloride. Now, here we have 1 atom of calcium with 2 electrons in the outermost shell, and it is not stable. To gain stability, it needs to lose 2 electrons and become positively charged. So we have chlorine atom here. Chlorine atom contains 7 electrons in the outermost shell, and it's not stable. In order to gain stability, chlorine atom needs to gain 1 electron, and since calcium is having 2 electrons in its outermost shell, Only one electron can be taken by one atom of chlorine, so it needs another atom of chlorine to take the other electron. So when calcium loses 2 electrons, it becomes positively charged with 2. Because 2 electrons are lost, calcium will have 2 extra protons. And 2 atoms of chlorine, after gaining 1 electron each, will become negatively charged with extra electrons. And there will be a force of attraction between these cation and anions. You can look at the example. And this type of bond that is formed between the negatively charged ions, anions, positively charged ions, cations, it is called ionic bond, and this is how calcium chloride is formed. The next example is potassium chloride. I have an atom of potassium containing 1 electron in its outermost shell, and it is not stable. In order to gain stability, it needs to lose 1 electron. And another example, I have chlorine atom having 7 electrons in its last shell, not stable again, needs to gain 1 electron. So it is going to gain the electron that is lost from potassium and become negatively charged. And when these two ions, potassium ion and chloride ion, when they are placed together, there will be a force of attraction between them, and that is how potassium chloride is formed. This bond is called ionic bond. Now let us summarize what we have learned about the formation of ionic bond. We have seen the formation of cations. Metal atoms loses electron to attain 2 and 8 valence electron, the result in the formation of cation and anion to form a bond, and this bond is called ionic bond. Now we are done with ionic bond. In order to learn about the next type of bond, let us see a video.
Huh? Huh? Oh. Oh.
Hmm? What did we learn from the video? What type of bond is formed between chlorine atoms? Okay, chlorine atoms are receivers of electrons. They gain or receive electrons to become stable. When two chlorine atoms form bond between them, none of them can lose electron. So there is no transfer of electron between chlorine atoms. How do atoms become stable? When they form covalent bond between them. Now when two chlorine atoms form bond between them, none of them lose electron. So they mutually contribute an electron each and share to achieve stable state, that is, have 8 electrons in their valence shell. How is the covalent bond different from ionic bond? Yes, we have already studied about ionic bond. Now you have watched the video. Now let us find the difference between covalent bond and ionic bond. Covalent bond, as you have seen from the video, is formed by sharing of electrons between two atoms, and ionic bond is formed by transfer of electrons between two atoms. Now let us find out the details in a nitrogen molecule. Following details. Okay, number 1, let us see number of electrons required to fulfill the octet state, that is, to have 8 electrons in their valence shell. Number 2, let us see how many pairs of electrons are shared to become stable. And number 3, how many bonds are formed between two atoms of nitrogen. Okay, formation of bond in nitrogen molecule. Let us look at the atom of nitrogen. Nitrogen atom is having 5 electrons in its outermost shell, and I have 2 atoms of nitrogen here. Now, how many? The first question, how many electrons are needed for nitrogen atom to be stable? Yes, they need 3 electrons. Now, can the 2 atoms of nitrogen transfer electrons to each other? No. So what do? They share. So, how many pairs of electrons are shared? There are 3 pairs. And how many electrons are there in total being shared between the 2 atoms? There are 6 electrons, each atom contributing 3 electrons each. That is how a nitrogen molecule is formed. And it is represented, each pair is represented by a dash, and you can see 3 dash there. It means that there is a triple covalent bond. Examples of covalent bond formation. Now let us look at some more examples of covalent bond formation. Number one, hydrogen molecule. Hydrogen molecule is formed by sharing a pair of electrons because each hydrogen electron or atom is having only one electron in its outermost shell. It cannot transfer, they need to share to form a bond. Next one is water molecule. Water molecule consists of one atom of oxygen and two atoms of hydrogen. And oxygen, as you know, there are 6 electrons in the outermost shell and it needs 2 electrons to be stable. And hydrogen, as you know, there is only 1 electron in its outermost shell and hydrogen cannot transfer electron to oxygen. Hydrogen will remain unstable. So in order to gain stability for all the atoms, they share electron and form water molecule. Next is methane molecule. This is methane molecule. Methane molecule contains 1 atom of carbon and 4 atoms of hydrogen. Carbon is having only 4 electrons in the outermost shell and then it fulfills its noble gas electronic configuration by sharing electrons with 4 atoms of hydrogen. Now you can look at the shared electrons in between and you can count. They have either 2 electrons in their valence shell or 8 electrons in their valence shell, and that is how they become stable. The line in between 2 hydrogen atom represents a single covalent bond, and line you can see running from oxygen atom to 1 atom of hydrogen and oxygen atom to another atom of hydrogen means that they are sharing a pair of electrons. Let us recollect what we have learned from the video and from the examples that I have given. Let us try to summarize. Atoms share electron to form covalent bond. They don't transfer, they share. Number 2, covalent bonds are formed when non-metal atoms combine. It's not between metal atoms, it is between the non-metal atoms. If just a pair or one pair or a pair is shared, a single covalent bond is formed. And if 2 pairs of electrons are shared, a double covalent bond is formed. If 3 pairs of electrons are shared, a triple covalent bond is formed. Now, look at this. Metal to non-metal. What type of bond is formed? Ionic bond. Non-metal to non-metal. What type of bond? It's a covalent bond. And now look at this. What type of bond will be formed here? Metal to metal. Guess? Okay. It's a metallic bond. Now let us look at what is a metallic bond. The valence electron in the metal atoms are held loosely by the nucleus. Thus the valence electron can easily free themselves from the atoms to wander about. So when the valence electrons leave their shell, the metal atoms then become metal ion. It becomes positively charged. You can look at this example here. Electron going away from the metal and metal becoming positively charged. Now where does these electrons go? The wandering free electrons in between the atoms, they form a sea of electrons. You can see the example here. And these sea of electrons are negatively charged and metal is positively charged. So there exists an electrostatic force of attraction between positive metal ions and wandering valence electrons and a bond is formed. This bond is called metallic bond. Now let us recollect and revise all 3 types of bonds that we have studied so far. First one is ionic bond. An ionic bond is formed by transfer of electrons from metal to non-metal atom and it contains charged particles. The force of attraction is between the positively charged cations and negatively charged anions. Next type of bond is covalent bond. Covalent bond is formed by sharing electrons between non-metal atoms and electrons are shared mutually. And the next type, the last type of bond we have studied is metallic bond. And it is a type of bond formed between the metal atoms. The force of attraction between the metal ions and the wandering or delocalized electrons. So these are the three types of bonds that we have studied today. And with this, I would like to give you all some questions. You need to write down the answer for these questions. The first question is, define a chemical bond in your own words. Question number 2 is, why do atoms form bond? Question number 3, how do atoms form bond? And question number 4, which of the following are more stable? Number A, oxygen atom or oxide ion, magnesium atom or magnesium ion, hydrogen molecule or hydrogen atom, nitrogen atom or nitrite ion, sodium atom or neon atom. So these are the questions. Thank you for attending my lesson. Kadinche.